Hi everyone, my name is Thomas Kim. Today is July 8th, 2019. This is my 50th episode about the future of C++ programming, C++ 2A standard. This is also second episode about the binary tree in C++. In this episode, we will learn how to search for a node in binary tree, and we will also learn how to generate the graphic representation of binary tree using Graphviz. Prerequisite. Please understand that you have to watch my previous episode about binary tree, episode 49. By clicking this link, you can watch my previous episode. And also, we'll be using Graphviz in this episode, so you have to install Graphviz on your machine. You have to watch this video about how to install Graphviz on Windows. Okay, let's get started. Start Visual Studio Code. If you open CPP extension folder, you can find the tutorials folder. Click this button, 050 binary tree 02 CPP. Hit enter. Please open binary tree, our previous source code, 049 binary tree 01 CPP. Ctrl A, Ctrl C, copy all, Ctrl V, paste all. Now close CPP1, Ctrl V. I will make some changes in my previous episode. Here, change it to Talk Play Fun, NL, Talk Play Fun, NL. And also, in this function, we will modify it to Talk Play Fun SS stream. Modify like this. I will remove this function. Delete. In ascending order, I will modify it to Talk Play Fun SS stream. Here I will say clear. I modified like this. Delete. Now start your command prompt. You should be in CPP extension tutorial folder, dir 050 star. You should find this file, cl ehsc std C++17 050 binary tree 02 cpp fe aexe. Hit enter. cls. You should build successfully. This is the state of our previous episode. Right after public section here, I will put it here. Binary. Note this is pointer. Find element type value. Okay, we are finding value. Please note that return type is pointer. If find fails, returns null ptr. If successful, it returns the pointer that points to the node that has the value like this. So we first test like this. If value equal this m value, then we found Okay, we found the value, so we can simply return this. Else if, say, not else if this m left is not null, return this m left find value. Please note that this is recursion. This is recursion. If this m right, this is also recursion. Return this m right find value. Okay, so we use recursion heavily. Now we will test this find function like this. I will simply copy it, copy, paste, test find binary tree. Here I will remove this part. If root find, we are trying to find a value, auto ptr. Since it has value 6, for example, 6, we inserted the value 6 here. We inserted value 6 to this binary tree stream, value found, ptr, and there. Else stream value 6 not found, and there. If auto ptr root find, say we haven't inserted a value 20. In this tree, binary tree, there is no value 20. So we are trying to find the value 20. Stream value found, ptr, and there. Else stream value 20 not found, and there. We will call this function copy, paste. Now we build once again. Wow, 485. I think I made some mistake. What's the problem? Sorry, I think I made some mistake. I will put else here. Then return null ptr. But this is not the problem. I have to fix. Now let's try once again. clang plus plus std c plus plus 17 050 binary 302 cpp, hit enter. I made a mistake here. I will create a function. Here. Element type get. Return this and value. Constant. Okay, I fixed this and I have to change it. Get. Copy. Paste. Now let's build once again. Okay, clang worked. So value 6 is found, but value 20 is not found. Because we inserted value 6, but value 20 is not in the binary tree. I think I made some mistake here. This is incorrect. I will fix like this. I will fix this part. If auto ptr if this is true, then return ptr. I have to fix like this. This is recursion, and I also made a mistake here. Now I can change it like this. I fixed like this. If true, then return. Now let's double check. 48, 48. Sorry. Return null ptr. I will also fix this part. If auto ptr return ptr. Okay. Now I will create another function, insert function. Here, template, type name, type name, types, void insert type arg types args. This insert arg if construct sphere size of arg not 0. This insert args. I will put bool return true only if all parameters are inserted successfully, otherwise returns false. Bool result return result, else return result. I created this function. Then we can try this. Instead of doing this, we can use like this. Root 8, 15, 7, 9, 12, 17, 6, 16, 18. I fixed like this. We can also try 20. We inserted 20, so it should return true. Now, okay, 20 found. Or if we put 25, it should fail. Okay, 20 not found. Now it seems to be working fine. I will fix this part. Instead of value not found, value not found, I fixed like this. Please note that in this function find, I think this syntax is very ugly, so I will create a ptr here, ptr, null ptr, and I will copy this part, cut, paste, like this, then return ptr. Also, I will copy this part, cut, paste, then return ptr. So please note that this is recursion. Find is recursion, also this part, recursion. Okay, find is used for recursion like this. Also here we use recursion. Okay, recursion, and I will find recursion 5 occurrence, and this also use recursion, and also here recursion. This is, I told it. So recursion plays very important role in advanced programming. Now let's move on to graphics. In our previous episode, in episode 48, in this video, we installed Graphviz. Okay, if you haven't installed Graphviz, please watch this video. And dot manual Graphviz. Please download this PDF files. If you open it, this gives some documentations about how to use dot. Okay, this is PS type. This is source code of GB, and this is output file format. Also, this is typical graph. I will explain how to use this syntax. Now search for, on your command prompt, right click, search zb edit. Okay, zb edit. Here, open file location, copy, paste it to your desktop like this. I will drag and drop it here. Put on your taskbar, start it, click this button. Let me see this PDF files. I will make it a little bit smaller. Digraph is directed graph. See, this is node. We will create a node like this. Node, I say node 1, node 2. Okay? And I create another node, node 1, node 3. Then we can print, we can graph like this. Say node 1, this is root node, okay? This node 1, let's see side by side. Then this is node 2 from node 1, node 2, node 3, like this. And another thing is that we can define node type like this. Node 1, style, oval, label, I say root node, root, okay? And I can define node 2, style, I will simply use oval, label, node 2. And I will copy once again. It is node 3, node 3. Then we run it. I probably made a syntax error. Oh, this is not style, this is shape. 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 For example, we can use box. Okay, now we run this. So this root node, this root comes from this label, and node 2, oval shape, this is oval shape, this is box shape. So this is basic syntax, okay, digraph. And with this information, we can create our own graph like this. Before we further proceed, let's build once again. Wow, 43. Sorry, I made mistake here. It should be enclosed in parentheses. Also here. Okay, now let's build once again. CLS. Okay, it works. Now I will define here using string t std string. I defined the string type. Then I will create here string t build digraph. We create talk play fun ss string os. We will create this start block like this, os digraph g. It doesn't matter, nl os. This closing curly brace like this, then return os str. Now here void print node talk play fun ss stream. This is reference. We first test this m left root node root to left side, okay, and root to right if this m right. We create this node first, node name like this, string t get node name, os talk play fun ss stream os node this m value return os str. We build node name, then we create this node properties, string t get node node definition. I will copy this for your reference. Talk play fun ss stream os. First we need to have node name get node name, because we created the node name here. Then I will copy up to this point, here. Then this m value, then we have to close this part like this, then return os str. So we created this node definition, Now here os get node name. Now we are drawing this part, this m left get node name, then semicolon nl. So we drawn this part, okay, node name. This is left child's node name, then semicolon, then end line. Then we call recursively like this. This m left print node os. We drawn left node, then here we draw right node, os get node name, this, and write, get node name, and L, this, and write, print, node OS. Please note that this is recursion for left children. This is also recursion for right children. Now we have drawn. Now we display this part. We can actually move it to here. We can do this too. So I will run it. The result is the same. Okay, so in this part, OS, this is node definition, get node definition, and L, like this. This is node definition. Please find some symmetry from this function and find the function. We first handle the value m, current node, then we test the left hand side and we call recursively. We test the right hand side, then we call recursively. In the same manner, we first handle this node definition, then we test the left node. If it is valid, then we call recursively. Okay, now we call this print node in this section. Print node OS, like this. Okay, we are calling this function. Now I think everything is done. Now we will call this build diagram like this. I will copy this function, copy, paste it, test, build diagram, and I will remove this part, and I will remove this stream root build diagram, and there. Now I call this function I will disable it in the command prompt. CLS. So this graph is created. I think there is something wrong. Let's test it. I copied it, and pasted it here. Wow. Why all these are boxes? Node definition, it is over. Now build once again. CLS. Now I copy it. Paste. Wow, this is the graph. I will put a space here, and I think this function is inefficient. Instead of this talk play fun SS stream OS, I will modify like this, and I don't need this. Then OS, this is more efficient. Also copy, paste, OS. We don't need this, and we return OS. I modified like this, and here we can put OS here, and also here OS. And OS. Also here OS, OS. Now let's build once again. "41, 41. It should be OS. And let's try once again. Okay. Now I copy it, paste. The result is the same. Now let's make command line interface. This is function main. I will disable it. INT ARGC, constant character pointer ARGB. If ARGC less than 2, stream usage ARGB 0 node list, and return 0. Binary node int root. It should be std atoi argb 1 for int I equals to I less than argc plus I root insert std atoi argb I stream root build diagram, and in the command prompt we build O bin binary tree exe, hit enter. Binary tree, okay, binary tree. We will use this text. I copied, paste. If we hit enter, we have a graph like this. Bin tree cv, hit enter, dir bin tree. So this file is created. dot tpng bin tree gb o binary tree png, hit enter. Tutorial folder bin tree is created. Wow, this graph is created. The source code of this graph is from here. So this is this graph. 10 at the root node, 8, 15, 8, 15, 6, 16, 18, 6, 16, 18. So I will copy this for your reference. Copy, paste it here. Binary 3 GB. Copied stream example, pasted RGB like this, and there stream dot tpng binary 3 GB or binary 3 PNG, and there we build once again binary 3. So binary 3 node list, binary 3, this is an example. This creates binary 3 PNG. I will post complete source code to my website, extension talkplayfun.com website. By the time you watch this video, you can click this button to download complete source code. Show in folder, unzip the folder, in CPP extension tutorial folder, you will find 050 binary tree O2 CPP. To compile this source code on your machine, you have to install latest version of Microsoft Visual C++, Visual Studio 2019 on your machine. Please watch this video if you haven't watched this video. Also, you have to install latest version of GNU G++. You have to install GNU G++ over MSys2 MinGW on Windows. You also need to install Intel threading building blocks. Please watch this video. Then you need to make system environment variable settings. By watching this video, you have to make system environment variables. Also, you have to watch this video, how to create this command prompt, also this command prompt. Then, in our previous episode, episode 48, in this episode we installed Graphviz. If you don't install Graphviz, you cannot generate graphic representation of binary tree. In our future episode, we will learn more advanced technique related with binary trees. And eventually, we will learn ABL binary tree, and we will also learn generalized trees. We will learn more and more advanced techniques in future episodes. So please make yourself familiar with recursive function call. Basically, you have to be able to implement all these code by yourself, because we will introduce more and more advanced technique in future episode. Please subscribe to my YouTube channel. Thank you for watching.